4.6, combinations. So there are two types of combinations. Remember that with a combination, order does not matter. The first type is where repetition is allowed. The second type is where no repetition, such as lottery numbers. So combinations without repetition. This should not be on here. All we need to do is adjust our permutation formula by dividing it by the number of ways the objects could be in order. So this is your new formula, NCR, where N is the total and R is how many you choose. So for example, what order could 16 pool balls be in? After choosing, say, number 14, you can't choose it again. So your first choice would have 16 possibilities, your next would be 15, and so on. So it would be, in other words, 16 factorial options. So that's your total number of choices. But then we need to, if we're only choosing 3 of them, we're going to need to divide it by that 3 factorial, and then the number of ways that, or numbers that you wouldn't choose. So if you're choosing 3 of them, that means you're not choosing 13 of them. So we could write this as 16 factorial over 3 factorial times 13 factorial. Because we're choosing 3 of them, we're not choosing 13 of them. So Explorer, 5 cards are dealt to each person in a card game. How many ways can you be dealt a hand that has only red cards? So only red cards means how many choices do you have? Total choices. 26. Good. So N is your 26. How many are you choosing? 5 of them. So how many are you not choosing? So there are 26 factorial total options. We'll divide that by the number we're choosing and the number we're not choosing. So note that these are the same things because we've got 26 total. It's a combination, so the order that our cards are in doesn't matter. We still have the same 5 cards, so we're only choosing 5 of them. So you're going to get 65,780. Okay, then investigate. Each year during the festival du Voyageur, not French, this year Bob's school is entering a 3-person team. 9 students have volunteered. So we've got 9 students to choose from. It's a 3-person team. Does your order matter? No, because you're going to have the same 3, or you're going to have 3 people. It doesn't matter who's standing where. So how can we write this? 9C3, or in other words, 9 factorial over 3 factorial and 6 factorial, which should give you 84. Apply. A restaurant serves 10 flavors of ice cream. Danielle has ordered a large sundae with 3 scoops. How many different combinations could she order? So there's 10, 3 scoops, 10C3. Are you sure it's not P3? How do you know? Because she just wants her ice cream. It doesn't matter what order they're in. If she said specifically that she wanted them in an order, you'd need to use permutation. So 10C3, 120 different ways she could get her ice cream. Example 2. Carly is the coach of a pole push team that consists of 9 players. So she has 5 males to choose from and 4 females. If she wants a team of all males, she's got 5 males and she needs 4 of them. So 5C4 is 5 possible teams. Now how many different 4-person teams could she choose from with 2 males and 2 females? So we've got 2 different things we need to consider. We need the males, which is 5C2 because we've got 5 males, we're choosing 2 of them. And we've got the women, which there's 4 of them, and we're choosing 2. And we'll multiply these 2 answers together. And this should give you 60. Example 3, last example. A planning committee is to be formed for a school-wide Earth Day program. There are 13 volunteers, 8 teachers, and 5 students. How many ways can the principal choose a 4-person committee that has at least 1 teacher? So let's figure out first how many total possibilities are there just total possibilities. Okay, there's 13 people total, and you're choosing how many? No, 4. So 13C4. So 5C4, 5 is the total number of students, and we're choosing 4 of them. Now in this case, this would be all the teams that had no teachers. So we need to subtract no teachers from our total to give us at least one teacher. And this would give us 710 options. You then have an assignment. It looks long, but they go really, really quickly.